Hello, so today I'm going to be going over the elephant toothpaste experiment for the interactive concept. So the materials used in this lab were the hydrogen peroxide. I used a 3% because that's what I had. There weren't any beauty supply stores around me. I couldn't find the right developer with 10% or higher. I used baking yeast as well, and dish soap that I had in my house, and food coloring. So these are just the formulas I found for each of the items. I did do the beginner level experiment, as I mentioned, just due to the materials that I had on hand and the difficulty of finding and ordering potassium iodide in time. So I did a couple of the experiments, or did it a couple times. The first time it actually worked surprisingly well, so this was my first experiment. I'm saying I'm adding the hydrogen peroxide, and this is me adding the food dyed. I tried to make a purple color. It wasn't as explosive as I expected it, but it did have like a thick foam consistency, and it was definitely hot. Afterwards, I felt I knew it was said not to touch it, but I just wanted to see how hot it was, and it wasn't super hot, but I definitely could feel the heat coming from the foam. And then for my second trial, I thought if I used more hydrogen peroxide, and then if I let the yeast froth up for a longer period of time, maybe it would be more explosive. So this is kind of what happened. I decided to do a green color instead. It was much slower than I anticipated it on being. And it had a much more liquid consistency, so I definitely had the wrong approach to making it better. I think just having the higher concentration of hydrogen peroxide would have been a better deal for or a better outcome. So this is definitely an example of an exothermic reaction, as the whole point of doing this. So I wrote down the reaction here. These are just the initial and final products, what happens to the hydrogen peroxide when it's decomposed. In this reaction, the yeast and the warm water act as a catalyst to decompose the hydrogen peroxide, and the dish soap reacts with the oxygen that's released from the hydrogen peroxide to trap the bubbles and to create the foam. And so I found that the entropy of the reaction, delta S, increases for this, and so it is positive. It's greater than 0 for spontaneous reactions. So positive delta S, spontaneous process, and this means that the reaction increased in randomness, therefore increased entropy. And because the process is spontaneous, delta H is negative. And so putting a positive delta S and negative delta H together, you always get a negative delta G, the Gibbs free energy equation I have at the bottom here. So regardless of temperature, this reaction will always be spontaneous. So reflecting on this experiment, I think that it does have a lot of applications. I think the most obvious one is that so yeast acts as a catalyst because of catalase, And this enzyme is why hydrogen peroxide is broken down into water and oxygen. And like as I mentioned before, the dish soap traps the oxygen bubbles to create the foam. In real life, I use hydrogen peroxide while I have it on in the house, as in antiseptic solution. Whenever you have a cut and you put hydrogen peroxide on it, you can see your cut kind of bubbling at the surface of the skin. So that's indicative that we have catalase in our bodies, and that's what's reacting with the hydrogen peroxide and killing germs. So I think that's pretty cool. Obviously, this reaction was way more fun than that. So this is definitely an important mechanism because our bodies produce hydrogen peroxide in low amounts, so that needs to be broken down so it doesn't become toxic in our system. So overall, really cool experiment for an exothermic reaction and seeing the principles of entropy and how they work.